Hello, thank you for staying tuned to my channel where we do our best to simplify the practice of quantity surveying. You're welcome to yet another interesting episode where we shall be calculating earthwork using the mean depth method for cut and fill on road construction. Are you watching me for the very first time? Please don't conclude without hitting the subscription button to encourage us to continue to do more. And if you have been following us for some time and you are yet to subscribe, please do. This is the only way you can encourage us to keep on turning out materials that are educative and adding to the body of knowledge in the pursuit of the profession of quantity surveying and engineering at large. Having said that, we are going to be using a detailed road construction design for this illustration. I will try my best to see how I make the video as short as possible. So please follow me with keen interest so as to understand my flow and understand every explanation that I'll be giving as we go. And I'm going to be navigating from the design to my spreadsheets that you see on my screen. The first thing is for me to go to the design, explain what the design entailed, then come back to the sheet to now use those data that I will explain. I will tell us those data on the spreadsheet on the design that I've transported to my spreadsheet, because I want to try as much as possible to reduce the watch time. So I've been able to move those data to my spreadsheet, as you can see on my screen. But the two data that I took from, or three data that I took from my design, basically are the road distance, that is the interval of change that were done by the surveyor, then the readings that were gotten in those change. Those are what I had brought in. Then, of course, there are procedures for application of the mean depth method of cut and fill. So those applications, I'll come back to explain how I had to now apply it using those data that I brought from the design. So having said this, let us quickly run to the design for us to get the brief before we now get back to my spreadsheet. So as you can see, I have a design for a 6 kilometer road, and what you have basically is these are the typical informations you're going to get that the designer will provide. As you can see, these are culvert schedule, sizes of culvert at every change that requires you provide a culvert. It has indicated it here, and the size of the culvert is 2 meter by 2 meter box culvert at plus 700 meters. You have a box culvert also, and all of that. So these are for the fact that we are not discussing culverts. Let's quickly just go straight to our area of interest, which is the cut and fill. Let's quickly rush down there. All these are details. So this cross section is important. So we need to explain what it means and how it affects our computation that we'll eventually do. The designer has given us a cross section and has told us where these cross sections will be applied. He said this is a typical cross section of road in built up areas, meaning if there are towns along the roads, when you get to those towns, town or communities, you need to provide drains on both sides. A box that is a U drain, a concrete U drain on both sides, and the road will camber from the center on both running towards direction, and it's at 2.5% graded. Then another cross section is where the road needed to slope towards one direction, and at this point you are cutting, because you can see the ground level is above the road formation level, meaning you are cutting down deep and you are creating this gully on both sides for the flow of water. Like the road is running towards that one direction, the water drops into this channel, and it now go towards the direction where it will be evacuated to either a stream or a river close by. So also, if on some portion of the road you are going to have a double slope in an area where it is still cut, because the ground level is high above the formation level. This is your formation level, and these are the stone base. Then you have the asphalt and above. So you are cutting through, and you are creating the same channel on both sides for the water to flow. Minus this ratio of 1:3 is very important to our computation. So have it at the back of your mind. When I am making reference to this 1:3, you should know where I'm picking it from. And the reason is not far-fetched. This is like it said, typical cross-section for cutting. So when I'm cutting down and I'm going to do an embankment. So the embankment now, this is the carriageway is 1.5. This is the shoulder carriageway is 3.65, and the shoulder is 1.5. So the total length of your formation will be about 10.5 up to this point. So it is from this point that the road begins to slope down. So if you draw this line downward, you have a right angle triangle. If you draw your line downward, you have a right angle triangle. So at a point, for you to get the cross sectional area, you take them separately by computing the midsection before you now compute this other right angle triangle on both sides, for you to now get your total square area multiplied by your distance to now have your cubic meter of the soil that you're either going to cut or you're going to fill. So that is why this ratio will be used when I am computing these two angles. Then this other section is talking about where you are going to fill above the ground level. As you can see, the ground level is beneath the formation level, and you are having an embankment, and you are either where you are going to fill and you are going to create an embankment. So this is where you are going to apply these details. So you see that there are different details for different location as you go. So the terrain will determine where you are going to apply either of these sections. So having given us explanation on the cross section, let us now go to the longitudinal section where the road is now cut across. This is the distance. This is the beginning of the road, and it's going all through this way. As you can see, I have the sheets for the readings they are in different sheets up till you get to kilometer 6,150 meters. That is 6.15 kilometer. So, but for want of time, we cannot compute the whole of this. We are just going to say few for the illustration, but typically it is repetition of the same. As you can see, the designer actually indicate where you have the bridges. These are signs, symbols. If you check the typical information they gave above, these are signs for the bridges, the culverts that were existing, and even at the cross section, he has indicated it, the box, and he said 1.5 by 1.5. This one, existing culvert in good condition, this will not be tampered with. Then existing culvert, both to be replaced by 1.5 by 1.5. So these two are probably not, they are bad, or it has been blocked, and the designer is requesting that the two should be replaced with this. So let's quickly, so this is this first two sheet is what we're going to use for relation. So basically what I did is to take my formation level, which is the blue. You see the design showing me the blue line going all through is the formation level, while the red line, Bennett, the formation level, is the natural ground level. So they took the reading on this plane. Then now the designer now did his design for the road. Now at this portion now it shows that you're going to feel, because this is the ground level, and now the formation level above this you're going to feel. Then you get to basically you are feeling all through. You are feeling all through. Then at this point, it's gradually almost coming to the same level, but it's not much and all of that. So basically, I am taking my chainage, and I'm taking my existing ground level and my formation level. Then I am taking the width of my road, which is the width of my road, which is 10.3, and I'm taking this 1:3 for my computation. So having said that, so basically we understand what we are taking: the formation level, the existing level, the chainage. The chainage is at 50 intervals. So at 0, 0, 0, at 25, at 50, at 50, at 75, at 100, at 125, 150, 175, 200. This is how it has been changed to the distance of 25 meters intervals. That is the distance between one chainage to another. So that also is very important that we keep at the back of our mind. So now let us quickly go to our design, our spreadsheet. So like I did said, I took my road distance, which is the chainage, which is 0 plus 0, 0, plus 0.25 plus 0.50 plus 0.75 and all. Then these are the readings that I transported from my design to my spreadsheet. Then the first thing I do is for me to get the depths of either fill or cut. So as you can see, the natural ground level is 285.81 at 00, while the formation level is at 285.811. So the difference between the natural ground level and the formation level is minus 0.001. So at 25, this change of 25, my natural ground level is at 284. The reading is 284.31, while my formation level is 285 point 285.075, meaning the formation level is higher than the natural ground level. So also at 50, I have 285 natural ground level, while formation level is 283. So the difference between the natural ground level, so this I needed to cut. Why this I am feeling. I am feeling here, I am cutting, I am cutting because the formation level is 282, why 0.53, why the natural ground level is 282 and 283. So you see that I am going to basically cut. So So having said that, first I've gotten my depth. So like I said, the first is to get your depth, which I did. I said natural gain level minus formation level gives me this depth. So after getting this, what I need to do is to drag through all through to the end where I have my readings. Then the next step is now to get my average mean depth. The reasons why this method is called the mean depth. This is the reason. So now it is now to add the first reading and the second reading and divide by 2 to get my mean depth. So what I did is to add the first and the second, the first chainage and the second chainage reading to have my, then divide by 2. You see it, E16 plus F16 divided by 2. Then I enter, then I drag all through as well. So I am also helping us to understand how the table was created. So the next one again is for me now to now bring my road width to the table. And like I said, if you add 3.65 by 2 plus 1.5 times 2 will give you 10.3. And that is what I did here. 1.5 times 2, 3.65 times 2 give me 10.2. Sorry, I also drag all through. I also drag because the width is all the same. Then now, like I did told us that now I want to calculate the central area of the cross section, which I am using this to also to give us an idea if the drawings, the detailed drawings was too boggled up with a lot of information that we cannot understand. So the road formation level is this, and this is the driveway and the shoulder is 10.3. But where you have the embankment, going towards this direction. They said the embankment gradient is 1:3. So for me now to get my cross-sectional area is to compute this first, then later compute this and this. But now, because this is a right angle triangle, if in some cases the gradients for the both sides are always sometimes not the same. So you might be having ratio 1:3 here, you're having ratio 1:2 here. So you will now compute it separately and divide by 2, add them together. But because if you bring these two right angle triangle, it will give you a rectangle. So normally it is like a waste of time you computing this divide by 2 multiply by 2. So once you compute this, you assume that you have taken care of these two. But because if they are two different gradients, slope gradient, then if they are two different, then that's when you're now going to compute this separately, divide by 2, compute this separately, divide by 2, then you add them together for you to now have your two-sided area. So that is what I am doing. I am doing here the central area M times B. So which is I am now multiplying the mean depth multiplied by the width, which is the 10.3, to give me that cross-sectional area. Then for me now to get the slopey side, it is the slope, because the slope now says ratio 1:3. So what you need to do is to divide 1 by 3, then you multiply your answer by the square root of the depth. You now have your area for the two. Like I said, if it is two different slopes, you have to divide by 2, add them together. So as you can see, I now did that. I took the mean depth, squared it, then multiply by 1 divided by 3. Then I'm not supposed to multiply by 2 because they are the same, and I have not divided the first one before I multiply by 2. So now enter, then I drag. I now drag. Then now the next step is to add the two sectional area, which is the middle, and the two-sided slope, which is this. So now the chainage is at 25 interval. So I now brought my distance between one chainage to another, which is 25, 25 all through. So now I now inserted the 25 for each of the chainage. Then for you now to now get your volume is to multiply the area, the cross section multiplied by your distance for each chainage. So you can see I multiply my total area multiplied by my chainage. It gives me the total volume that I needed. So also I will now drag. So if you create, say, if you create this template, if you create one of these templates, like I did said, that why I am doing my own, I'm taking each sheet separately, it's for ease of reference and fast checking in case I want to check if there are errors rather than going all through. Nothing stops me from taking the whole 6 kilometer just in one stretch like this up to the end, but it will be either cumbersome to manage. But if I take each sheet and I impute, so if I want to check now, I just pick one of the sheet, maybe the hard copy of the sheet, I check this reading all through. And once I am done with this sheet, I pick the next sheet. I am done with the next sheet. I pick the next sheet. I am done up till the end. I'll be able to check fast. But maybe if I have all my readings running all through in these directions, some persons can handle it. Some persons might not be able to handle it. So me, I had to break my to just take them each. So as soon as I get one of those format done and dusted, what I just needed to do is just to copy. I copy, I paste, I take out all of these readings. I take all of these readings, I take the next sheet, I impute all of these readings. Once I start imputing 257.1, then maybe 256.2, my quantities will start coming automatically. So it makes your work faster, easier, and you can easily correct your work if there are errors, and everything will be corrected. So after doing that, because my table has the combination of both cut and fill, so now for me to cipher it out, yes, there's something I needed to point out, like the slope. As you can see, Excel has a lot that you can exploit to ease your job. You can impute your square if you want to get the square of a particular number. What you can see here, you see on your keyboard, you look for the sign that is an angle sign that is showing upwards like this. You press the shift key, and you press the shift key, hold the shift key down, and now press that key. It will now, this sign will now come up. Then you now add 2, meaning that you have squared that number. Then I now multiply by what I divided in the bracket, which is the gradient of 1:3, divided it to now have my square area. So also I came to this other area too. Now, because I have combination of both cut and fill in this direction. I now came again, use the same if in my computer to now tell the computer that you should sum up everything that is less than 0 in one cell and sum up anything that is greater than 0 on the other cell. So it now aggregated the negative sign, which is the fill, while the cut, the positive is the cut based on my reading. I now have 4,093.79 cubic meter of soil to cut, while I have 402.63 cubic meter to fill, the areas to fill. So I now went further again to now, after maybe I have computed all of these changes to my 6 meters. So now I come down here and I said, okay, some vertical, all the figures that are less than 0, and also do the same thing for figures that are more than greater than 0. It now sum up. So what I am going to be filling, areas I'm going to fill, is a 9,046.64 cubic meter of soil. Where areas I'm going to cut is just 466.8 cubic meter. So this quantity is what I'm transferring to my bill, then apply my rates. Immediately I am done and dusted. So please, if I've been able to help us or guide us on how to use computer and also how to use the mean depth method to get your quantities for excavation, please leave a comment on my page. If you have any challenge, you can leave also a comment on my page, a question on my page. I'm going to answer. I'm going to definitely respond to your worries. Above all, don't forget to hit the subscription button to encourage us to continue to guide us, to help us to do more. Thank you. See you next on the next episode.